Alright, now we have finished learning all types of linked lists and we have explored different operations that can be performed on linked list. Now in this video, let's compare the time complexity of all operations that we can perform on array and linked list. It's very important to do so because knowing the time complexity of different operations on these data structures helps us to select the best option for our case. So let's get started. So here we are starting with the first operation, which is creation operation. Now in case of creation, when we are creating an array or linked list, both of them take constant time operation. Because in this case, when we are creating an array, we are just initializing the cells in the memory with default value and it takes O1 time complexity. And in case of linked list, we are just creating one node and creating a link between head and this node and tail and this node. So this takes O1 time complexity. Now when it comes to insertion at first position, in case of array, it takes O1 time complexity because in this case we are just using array index to access the first cell's location and updating its location. And in case of linked list, this one also takes O1 time complexity because in this case we are just creating a link between head and newly created node. Then we are updating the next reference of this node to point to the second node. So here we are just updating the references of head and tail and the second node based on the type of linked list. So this means that it will take O1 time complexity because here extra time is not required to perform these operations. Now the next operation is insertion at the last position. Now when we are inserting at last position, in case of array, so here also we are accessing the last position using array index and updating that value. So this will take O1 time complexity. And in case of linked list, we just need to update the references based on tail. So by using tail, we can access the last element in linked list without any loop. So here based on tail reference, we can do our operations and insert an element at the end of linked list. So this means that it will take O1 time complexity because in this case we are not looping through linked list. Now the next operation is insertion at end position. Now in case of array, this one will take O1 time complexity because here also we are going to use n to access the cell and update that value in the array. But in case of linked list, we have to loop through the linked list until we find the nth location. So when we find it, we are going to change the references of these nodes and update their references to insert a new node at this location. So that's why this loop will take O(n) time complexity. Now when it comes to searching in unsorted data, in case of array, it takes O(n) time complexity because here we are doing linear search. So this means that we have to loop through the elements one by one and checking that if this is the element that we are looking for or not. So this will take O(n) time complexity. Now in case of array, this will take also O(n) time complexity because the same logic is applicable over here. Here also we are doing linear search. So we are searching through the nodes one by one and checking that if this is the node that we are looking for or not. Then the next operation is searching in sorted data. Now in case of array, when we are searching in sorted data, we can implement binary search. So this will take O(n) time complexity. So we are going to talk about binary search in our searching algorithm sections. At this moment, you just need to know that if you are searching in sorted array, it takes O(n) time complexity. Now, in case of linked list, it doesn't matter because here also we are going to do linear search. That's why it takes O(n) time complexity because in this case, we have to visit all nodes one by one and check that if this is the node that we are looking for or not. Then when it comes to traversing, so we know that in case of traversing, we have to visit all elements of the data structure and print out their value to the console. Now in both data structures, arrays and in linked list, we have to visit all elements and printing out the values. So if the number of elements in these data structures is n, so the time complexity will be O(n) because here we have to visit all nodes of data structure. Now the next operation is deleting at first position. Now when we are deleting from first position of array, we are just accessing the first cell and updating its value to the default value. So this will take O(n) time complexity, and in case of linked list also this will take O(n) time complexity because in this case we are going to just set head and tail references to null based on the linked list type. Now the next operation is deleting at last position. Now in case of array, same is applicable over here. Based on index, we are going to access the last cell and update its value to default. So with this, we are deleting the last element from the array. But in case of linked list, for example, in case of single linked list, if we want to delete the last element from the linked list, we have to traverse through the linked list until we reach the element that is located before the last element. Then we are updating the references of this element. But in case of, for example, double linked list, we don't have to traverse through the double linked list until we reach the last node. We can just access the node that is located before the last node by using previous reference of last node. So in this case, in case of double linked list, it takes O1 time complexity. In case of single linked list, it takes On time complexity. Now, when it comes to deletion at nth position, here also, in case of array, we just need to access the cell and update its values. So based on n, we are going to access the nth cell and update its value to the default value. So with this, we are deleting the cell from the array. But in case of linked list, we have to loop through the linked list until we find the specified location and delete element from there. So this means that this loop will take On time complexity. Now, when it comes to this operation, deletion of array and linked list, in case of array, it takes O1 time complexity. When it comes to linked list, it might take On or O1. In case of single linked list, it takes O1 time complexity because here we just need to update the tail and head references to null, and then all elements will be deleted automatically. But in case of double linked list, we have to loop through the double linked list to update the previous references of all nodes to null. So this loop will take On time complexity. So deletion of entire linked list in case of double linked list will take On time complexity. Now, when it comes to accessing nth element, in case of array, it takes O1 time complexity because here we know the physical location of cells from the beginning. That's why it takes O1 time complexity. But in linked list, we don't know the physical location of the nth element. So to go to nth element, we have to loop through the linked list until we find the specified location. So that's why it takes On time complexity. Now with this, we have come to the end of this lecture. So in this lecture, we have compared time complexities of various operations that we can perform on array and linked list. Now hopefully everything is clear about this lecture. Now see you in the next lecture.